looks like nobody else is showing up in time, then we won't wait. I would say, Dr. Rattan, as usual, you start with a recap from yesterday, and everybody
Absolutely.
enjoys the last day of training, and you work as long as it takes that you know everything about Python. So if I see if I see you here still by midnight, okay, then we have a problem. Then we should do another class next week. No, I'm just kidding. Okay, enjoy your day today. Okay, Dr. Rattan,
Right.
start.
Yeah, thanks a lot for that. All right, so yeah, hey Ben, hey OST. So yeah, let me just share my screen and let's get started. So first up, I hope you're both able to hear me properly and see the screen. Just let me know so we can go ahead right away. All right, yes, perfect. All right, then let's get back to where we were. Over the last session, we started to take a look at a couple of very important parts of Python, that is um, asynchronous operations, as well as multi-threading. And we also saw where to use which one of them. In case of CPU intensive operations, which one to use. And in case of network intensive operations, which one to use. And we made our way to learn pandas. And this is exactly what we're going to continue with. We're going to do some small exercises with pandas utilizing the other knowledge that we have. And once we do that, our next step after that is to go and connect to the database so that we can perform some operations on top of database in our application. So if you remember, we have our own application for text to speech. So we're going to send some additional information about user in text to speech, and we're going to say, hey, this particular user has done 100 translations, and that's all they can do. If they want to do more than that, they need to pay and use our paid service or something like that. We'll try to do something similar to that so that we can see how to incorporate database into a real world application. So this is what we're going to start with. We have a few other things that we'll learn on the way along as well. But prior to that, if you have any queries on the concepts that we have worked on till now, please let me know. Please feel free to let me know. So I will walk through them and I'll just take a look at them so I can express them in different views. Or if you'd like me to take up more analogies or examples, we can do that. So yeah, please let me know if any. We'll take that up. If not, we'll get started right away with the next topic. All right, in that case, I presume there are no specific queries, which means we can uh, go ahead and begin. So that sounds great. Let's do that. Moving ahead. Let's continue from where we left off with the pandas. I hope you're all able to access this particular data set of pandas so that we can learn some part of pandas initially. And I hope you also have access to this interactive Python notebook that we have so that you can access the code that we have done till now. Our main purpose is just to learn some basic operations of pandas so that we can utilize them ahead in a few applications. So all you need to know is as long as you're able to just perform these basic operations in pandas, then we're good to go. It should not be um, a difficult thing ahead of that to continue ahead. So yeah, let's go ahead and continue ahead from where we left off now. In our current case scenario, based on what we have learned and what we have worked on, let's go on to the next part. Here, so far, what we have learned is that whenever we go through a data frame, we have two specific functions. One is called LOC, another is called ILOC. Iloc is a function that will take index as the input. It will take a row index and a column index. So using this row and column index, you can access an individual cell, just like in Excel, you might access an individual cell like A3 um, or B24 or whatever it could be. Similar to that, we just provide the row, which will be the row ID or row index 0, 1, 2, or whatever it is. Similarly, the column index, which is 0, 1, 2, or whatever it could be. Instead of accessing just one cell, we also learned that using Iloc, we can access a series of cells as well. Like I can access first 5 rows and all the columns. All the columns is just write colon. It'll go from start to end by default. Or if you want to access all the all the rows, but first 5 columns. A lot of these possibilities, a lot of these combinations can be done based on what we have seen. This is how iLoc works, just for our reference. Once we scroll up, I think we have taken a few examples. Yeah, there we go. All rows, column number 0 to 5, and so on. You can perform a lot of different modifications, like I need column number 0 to 10, and I need you to skip one column at a time. If there is such a scenario, you can do that. Okay, let me run all of them. I've just clicked on run all cells because I need to start running from the first cell, which will install these things and so on. Oh, yeah, prior to that, I forgot to move to our virtual environment. Let's do that. Right now, I'll have to run this again. Right, and there we go. And you can see we are able to get column number 0 to 9, skipping 2 columns at a time. So after number, there's supposed to be name, if you remember, but we are skipping name and going directly to type 1 and so on. And yeah, this is pretty much how you can perform simple access operations or simple query operations to access elements based on their indices within Python, that is particularly using pandas. Once we do that, our next step is to utilize these ahead in other functions. It could be functions where you need to perform some search operations, functions where you need to perform some filter operations, could be a lot of them. And that's where we're starting here. We're trying to first, in our case, filter all the, let's say, all the Pokemons that are fire type. And here's how we're doing it. So if you remember this, let me get back to this. Yeah, if you remember, in a data frame, loc is a function that will take a series as input. That series as input can have true and false values. Now here's the condition. If you have the following, let's say, column or series, which has 1, 2, 3, 4, and 5, and you somehow generate another column where you get to know which of these are even and odd. So to get to know which of these are even and odd, we run a simple function. Let's say if the column name is numbers, we'll just take df of numbers that we have, and we just check if it is divisible by 2 or not. That is, if mod 2 is equal to 0. Once you run this, it will take each element of this and perform mod 2 with it and check if the remainder is 0 or not. In this case, the remainder is not 0, so it says false. For the second one, it says true. For the third one, it says false. For the fourth one, it says true. For the fifth one, it says false. Now that we have this array, I just need to place this array in df.loc. When I do this, it'll apply this filter over this data frame or series that we have. And whatever matches true, it'll retain only those elements. This is what it does. And that's exactly what we have done in our case as well, in order to obtain and identify how to work around this. So let's get started and um, let's see how this specifically works. We have seen one small example in the last moments of our previous session where we performed this following operation. If you perform just this, df of type 1 equals fire. Wherever within the entire data frame, type 1 is fire. You can see for row number 4, type 1 is fire. And for the value with 721, type 1 is fire. You can see the last value, type 1 is fire, which means it is true. And the fourth value as well, type 1 is fire. So for the fourth one also it's true. Now that we have such a true false based series, we're just going to keep this as a parameter within loc function. So this is going to be label based, but may also be used with Boolean array. So there are two purposes of it. Label based, which is based on column name, but you can also use it with Boolean array. So currently we are using it with Boolean array. We're going to use it with label probably later on. So let's try running this. If you run this, wherever it is true, only those rows are retained, and you get to see those are the values we get to find here. This is how you can filter elements or filter things with loc function to begin with. Now, before we move ahead to the next one, there's another way to use loc that is based on label. If I write df.loc of name, you can see, okay, let's see what happened. There's a key error name. Oh, yeah, I think I made a slight mistake. Let's write df of name. Okay, oh, it got the indices, but it won't be able to print it. All right, so let's apply a function on top of it instead to understand this better, how to access the values. Right. Now, with this, let me just print head to show you a few things so that we can apply a function on it. All right, so the function I'm going to apply is there are a few Pokemons that end with SAUR. This is what we have, right? So we know a few Pokemons end with SAUR at the beginning, or sorry, as the suffix. Now, the whole idea is I just need to make sure that whatever Pokemon I am searching for or whatever Pokemon I am filtering, I have to make sure that it has SAUR at the end. In order to do that, we will perform the exact operation that we are performing as of now. Remember, our simple idea is whenever we use loc, we use a Boolean array within it to begin with. So I'm just going to have to create a Boolean array. I need to find all the names that end with SAUR. This is what I need to figure out. And here's how we can work around it. If you go to df of name, it will give you this entire series. Df of name will give you the entire column that is name. Now, in our case, when we talk about df of name, I need to find out which one of these end with SAUR. And there's an easy way to work around this. Pandas allow you to perform the following function on any column at all. If you have a particular column, like df of name, and you want to take this name value as a string and then apply some string function, you can use .str after it. So you can apply string function on every single value of this column name. That's exactly what we want to do. We want to take this column name that we have, and we want to apply a simple function. By converting this name to string, or by considering this name as a string, we want to apply a string function. You can apply any string function here that is capitalize or upper or whatever it is. I want to know if it ends with SAUR. So for this, we have an inbuilt string function that just starts with this, ends with. This particular inbuilt string function we can use, and within ends with, I'll just specify SAUR. This will tell me which strings end with SAUR and which don't. So if I run .str, you get to see it creates a string method object. This means that each element of this column is converted to a string format on top of which we can perform some operations. Right. Now, here's what we need to do. Within string, I just need to check. Again, we have so many functions. I just need to find if it ends with SAUR. Once I do this, we'll get true and false values. And we know what to do with this. We just wrap around it with loc. And once we do that, we're done. We'll get to know all the Pokemons that end with SAUR. Apparently, it's the first 4 Pokemon we see and none other than that, but we get to see it like this, right? Anyway, moving ahead, let's go for complex filtering ahead. We have performed a simple filtering like one filter, like whether it ends with SAUR or the type is fire or so on, but we're going to apply multiple filters up next. However, before we do that, if there are any queries till here, before we move ahead, please feel free to let me know. I'll walk through any questions you might have. I'll respond to them and then we'll move ahead to the next condition. So please feel free to let me know if there are any queries whatsoever. All right, so no queries particularly, which means we can move ahead to the next part of this. So let's do that. Now, the next thing that we will start to look at is some complex filtering. So to do that, let's create some filtering ideas. Let's say I want to know all the Pokemon that are, let's say, fire type again. Let's say find out all the Pokemon that are fire type. And let's add one more condition. Let's add two conditions. The reason why I'm adding these conditional complex filtering is because conditional or complex based filterings are different in the way they work compared to um, Python. It's not the same thing that we have in Python. What we have here is slightly different. So that's why we need to take a look at this and try to understand how they work. So let's take a look at this. What we're going to do here is find out if a Pokemon is of fire type and its health point is greater than 80. That's exactly what we need to do. Now, how do I do this? Because let's talk about this. We have two conditions, not one, but two specific conditions. First condition is to check if they are fire type, and the second condition is to check if their health points is greater than 80. In Python, we have AND keyword for two conditions together. In pandas, we do not use this. Internally within pandas, we cannot use AND keyword. Instead, we have to use a single ampersand. So let's remember, whenever we go for pandas condition, AND is replaced by AND, OR is replaced by OR symbol, and NOT is replaced by NOT symbol. So this is one thing that we just need to know, particularly about pandas in terms of conditions. So let's apply them. So we have two conditions to begin with. In our data frame, type 1 should be equal to fire. This is our first condition. Okay, so this is a string. This is our first condition. And let's write this first. The other condition is the of HP or health points should be greater than 80. This is our second condition. Now, if you observe here, it says truth value of this series is ambiguous. Use something else. Here's why this happens. When you perform this operation, just for us to know and understand why this is happening, take a look at this. In our case, when you run this, the first value of this, whatever we have, is going to give a series of true and false values. The second one is also going to give us a series of true and false values. Whenever you have true and false values, you cannot apply AND with it. Instead, what it's saying here is the truth value of series is ambiguous. Use a boolean or empty or any or all, but you cannot use AND over here. So let's see what else we can do. Let's put a couple of brackets around it, and I'll tell you why this is quite important before we go ahead. Once you run this, of course, we'll still get the same error. However, let me replace it with ampersand with Python accepts. If you run this, you'll get this response. So the idea here is that Python with pandas is not going to allow you to perform this operation with the word and. Instead, you have to use ampersand. But when you do that, it'll ask one more error. It'll say one more error. You cannot do this because both of these are of types that are series. You cannot perform this operation directly. So you have to actually wrap them around a tuple and then perform this operation. That's the only way for us to do that. We are just wrapping them as a tuple and performing AND. It'll perform the AND operation between them and give us the result. So we get to know all the Pokemon that have type 1 fire and HP greater than 80. So wherever both of these are true, only then the result will be true. Wherever either one of them is false, the result will be false. To know which are the values that come up here, I'm just going to use Df.loc, and I'm just going to apply this function over and run this. You get to see these are the fire Pokemon that have HP greater than 80, for instance. Just some simple thing that we are working on. Again, it's just a fairly simple thing that we're just taking a look at. So if there are any particular queries, again, till here that you might have, please feel free to ask and let me know so I will answer the same or respond to the same. I'll just take a few seconds if you have any queries whatsoever. If none, we'll just move ahead to further concepts and further things within Python. So please let me know if there are any queries whatsoever. All right, so no specific queries in that case, which means we can move ahead and yeah, let's go ahead and continue in that case. Now, one of the first things that we need to know, one of the most important things that we need to know when it comes down to multiple conditions is that you might not just have only two conditions. You might have more than two conditions that you have to search around, that you have to work around, you have to perform some operation on, and so on. That might be a scenario as well. So let's take a look at how that is done, how we perform operations on those as well. Now, first things first. In our current case, given our current example, given that we have understood to an extent how filtering works within this, let's go ahead to the next part. Also, hey Eric, Nick, and Brianna, welcome. I probably did not notice you guys earlier, so right. So
Hello.
let's take hey. So yeah, let's take a look at the next function. We have a function called describe. This particular function will give you the statistical response or statistical information only for the columns that have numerical values. Take a look at this. Hash, number has a numerical value. HP has a numerical value. Name does not. Type 1 and type 2 do not have numerical values. They have text-based values. Legendary does not have a numerical value. Again, text-based values. So any column that has text-based values, it won't affect it. It will not give you a response. Any column that has numerical value, it'll give you a response of it. That is, how many values are there? What is the mean of it? What is the standard deviation? How much it's moving apart from its mean value on an average? What is the minimum value? What's the 25 percentile, 50 percentile, 75 percentile? What's the max? All of these you get to know. So if you want to perform some mathematical operation, get to figure out something like this. This is how we figure it out. Now, since we have done one simple um, filtering operation, I'm just going to ask you to do one filtering operation. So just remember, we have done one filtering operation here, that is to find out if it's a fire type Pokemon and if its health points are greater than 80 or not. What I want you to do instead is, hopefully you have the Python notebook and the dataset along with you. However, if you're unable to, you can let me know. I'll just skip this and just execute it by myself as quickly as I can, if in case you're unable to access or perform the same. But here's what I want to do. I want to figure out all the Pokemon. So I'm not sure whether we call Pokemon or Pokemons in terms of plural, so I'm just gonna keep it as it is. So let's say we want to find all the Pokemon that are either either as in we're gonna use or condition, either fire type or water type, and their HP must be greater than 100. So this is the condition that I want to add up. So I just want you to try this out. Take a minute maybe. Let's see if you are able to figure out. We have seen the previous condition and we have seen how it works. So I just want you to apply similar to that to this particular condition and see how you can work around it. Should be fairly simple. If you have any difficulties with this, that is to work around this within the next minute, that's all right. But if you are able to, that's pretty awesome. So let's just give it a try. Let me know if you are able to work around it though. Right, just take a few seconds. If you're able to do it, that's fine. If not, that's totally cool. We will try to work around it right after that. Again, the same logic. You're going to use df.loc, and within loc, you're going to add the following condition. That is, it should either be fire type or water type, and its health point must be greater than 100. Let's observe this first. Let's see what takes preference in this case. Right. So what takes preference in our case is, in our condition or in our given scenario, is that, all right, I'm terribly sorry. I might need to be on mute for just a few seconds. So I'm just going to keep my kitchen aside so that I can focus on the session. So please hold on for just a few seconds. Apologies for the slight delay. All right, so getting back to this. And we have got an answer. That's pretty awesome. This is quite a good way to work around it. So yeah, we've got an awesome answer. Thanks a lot, Baron, for working this out. So that's pretty cool. So let's try this out and let's see how this works. So this is absolutely perfect. I will make just one change. That's just a cosmetic change compared to this, nothing else. Right. I think one bracket is missed out here. If I'm not, okay, it's here. All right. So here's what we have. We have to select type 1 is fire or type 1 is grass. This is what we're selecting. And please observe this. This is placed in a separate bracket. The reason this is placed in a separate bracket is this must take higher priority than this. The default idea of programming languages is and takes higher priority than or. So if you don't use brackets here and here, it'll perform this first. That is, the Pokemon should have